Vitamin A plays a vital role in our biology. It supports vision, immune system function, skin health, and cellular communication. It's also critical for gene expression and reproductive health. But like many nutrients, especially those that are fat-soluble, more isn't always better. In fact, when it comes to seniors, people over the age of 60, there are compelling reasons to carefully reconsider how much vitamin they are taking and whether supplementation is even appropriate at all. The first thing we need to understand is that vitamin A is a fat-soluble vitamin. That means it gets stored in the body's fatty tissues and the liver. Unlike water-soluble vitamins like B-complex or vitamin C, which are excreted in urine if taken in excess, fat-soluble vitamins accumulate. This accumulation can eventually lead to toxicity, a condition known as hypervitaminosis A, which can be particularly dangerous in older adults. As we age, our liver function tends to decline slightly, and our body's ability to metabolize and clear excess compounds becomes less efficient. This makes seniors more vulnerable to the buildup of fat-soluble vitamins like A. Even if you aren't taking massive doses every day, the long-term use of standard over-the-counter multivitamins that contain vitamin A, especially in the form of retinol or retinyl palmitate, can gradually raise blood levels to a point that becomes physiologically harmful. What does vitamin A toxicity look like? It often begins subtly: fatigue, nausea, dizziness, and headaches. These symptoms are easily dismissed or misattributed to age or medication side effects. But over time, excess vitamin A can lead to serious complications, including liver damage, increased intracranial pressure, skin desquamation peeling, and even cognitive disturbances. One of the most concerning and well-documented risks, however, is bone demineralization. There is growing scientific consensus that high levels of performed vitamin A, again, particularly in supplement form, can weaken bones. Several epidemiological studies have shown that excessive vitamin A intake correlates with lower bone mineral density and a significantly increased risk of hip fractures in older adults. This is incredibly important because seniors are already at heightened risk for osteoporosis and falls. Anything that increases bone fragility in this population is, frankly, dangerous. The mechanism behind this appears to be related to how vitamin A affects osteoblasts and osteoclasts, the cells that build and break down bone. High vitamin A intake suppresses osteoblast activity, which builds bone, and stimulates osteoclasts, which resorb bone. This creates a negative balance, tipping the scales toward bone loss. So, ironically, the very nutrient that's sometimes marketed as supportive for skin and structural health may be quietly undermining the skeletal integrity of older adults. Another often overlooked issue is redundancy in supplementation. Seniors may be getting adequate or even high amounts of vitamin A through food. Liver, dairy products, eggs, and fortified cereals are all rich in performed vitamin A, and many vegetables like carrots and sweet potatoes contain beta-carotene, a precursor that the body converts into active vitamin as needed. This built-in regulation helps avoid toxicity from food sources. But when you add supplements to an already sufficient diet, you override that protective mechanism. What's more, many popular multivitamins marketed toward older adults still include significant amounts of performed vitamin A. When taken daily over months and years, this can push total intake well beyond the recommended upper limit, which for adults is around 3,000 micrograms per day, 10,000 EU. But studies have shown that even doses below this threshold, when taken chronically, can negatively affect bone health. Another consideration is the interaction of vitamin A with other nutrients. For example, high vitamin A can antagonize vitamin D, another fat-soluble vitamin that's crucial for calcium absorption and bone strength. This interaction might further impair skeletal health, especially if vitamin D status is marginal to begin with, a common issue in older populations. So what should seniors do? The first step is not panic, it's precision. If you're over 60, it's wise to get your blood levels tested, including serum retinol and liver enzyme markers. Then evaluate your total intake. Look at your diet, your multivitamin, and any other supplements. Most importantly, avoid unnecessary high-dose vitamin in a supplementation unless prescribed by a healthcare provider for a specific deficiency. When in doubt, prioritize getting vitamin through whole foods, especially beta-carotene-rich vegetables, which offer the benefit of self-regulating conversion based on the body's needs. In summary, while vitamin A is essential to health, in the context of aging, it requires more careful management. What was helpful in youth may, if unchecked, become harmful in later years. The goal is always balance, optimizing function without tipping into excess, and that starts with understanding the biochemistry, respecting the nuances of aging, and personalizing nutrition accordingly. Vitamin E is widely known and marketed as a powerful antioxidant, something that helps protect cells from oxidative stress, supports immune function, and may even slow aging. For decades, it's been included in multivitamins and standalone supplements with the promise of improving heart health, preserving vision, and fighting off age-related degeneration. But as with many things in biology, the story is more complex. When we examine the research, particularly in the context of aging, what emerges is a pattern that urges caution. For seniors, excessive or unnecessary vitamin E supplementation may not just be unhelpful, it could actually be harmful. To understand why, it's helpful to look at the mechanisms of how antioxidants work in the body. Vitamin E refers to a group of fat-soluble compounds, primarily tocopherols and tocotrienols, with alpha-tocopherol being the most biologically active form in humans. It's stored in fatty tissues and cell membranes where it helps neutralize free radicals, unstable molecules that can damage cells, proteins, and DNA. In theory, this sounds entirely beneficial. Oxidative stress, after all, is associated with aging, cancer, heart disease, and cognitive decline. But here's where things get interesting. While a small amount of oxidative activity in the body is damaging, some oxidative signaling is essential. It plays roles in immune defense, hormone production, and even mitochondrial function. When we oversuppress this natural process, especially chronically with high-dose supplementation, we risk disrupting critical signaling pathways. This is where vitamin E's potential to shift from antioxidant to pro-oxidant becomes a concern. Studies have shown that high doses of vitamin E, typically over 400 IU per day, and lead to a paradoxical increase in oxidative damage. This happens because excess alpha-tocopherol can undergo oxidation itself, producing tocopheroxyl radicals. If the body's antioxidant recycling system, which relies on compounds like vitamin C and glutathione, isn't functioning optimally, which is often the case in older adults, these radicals don't get neutralized. Instead, they can start to attack lipids, proteins, and even DNA, thereby amplifying oxidative stress rather than reducing it. Furthermore, clinical trials have raised serious questions about the long-term safety of high-dose vitamin E supplementation in older populations. A major meta-analysis published in Annals of Internal Medicine found that individuals taking more than 400 IU of vitamin E daily had a higher risk of all-cause mortality compared to those not supplementing. Other studies have linked high vitamin E intake to an increased risk of hemorrhagic stroke, likely due to its blood-thinning effects. This is particularly important for seniors who are often on anticoagulant medications like warfarin or aspirin. Vitamin E can amplify their effects and increase the risk of internal bleeding, especially in the brain. Another aspect worth discussing is how high dose vitamin E affects other nutrients. When taken in excess, it can interfere with the absorption and metabolism of vitamin K, which is essential for blood clotting and bone health. It can also disrupt the balance between different forms of vitamin E. Most supplements contain only alpha-tocopherol, but the body also uses gamma-tocopherol and various tocotrienols, which have their own unique biological effects. Overloading on alpha-tocopherol can actually suppress these other forms, leading to a narrower and potentially less effective antioxidant profile in the body. Now, all of this doesn't mean vitamin E is inherently bad. It is, in fact, essential. It supports immune function, protects against lipid peroxidation, and helps maintain the integrity of cell membranes. The real issue is context and dosage. The average adult requires about 15 milligrams or 22.4 IU of vitamin E per day, and most people meet this through food. Sources like nuts, seeds, spinach, and vegetable oils. The body is very efficient at regulating vitamin E levels from diet. It absorbs what it needs and excretes the rest. It's when we intervene with high-dose supplements, often without clear medical need or biological markers, that problems begin to arise. In older adults, the metabolism of fat-soluble vitamins slows down. Combined with the common habit of taking daily multivitamins or single nutrient supplements just in case, this can lead to cumulative toxicity over time. And because symptoms of early vitamin E excess are subtle, fatigue, muscle weakness, headache, they often go unnoticed until more serious consequences occur. The science continues to evolve, but one thing is clear. For most seniors, the emphasis should be on getting vitamin E from whole food sources, not from large dose pills. Supplementation should be considered only when there's a verified deficiency, ideally confirmed through blood testing and under the guidance of a healthcare professional. In conclusion, vitamin E isn't just good or bad, it's a powerful compound that, like all tools in biology, depends entirely on how, when, and why it's used. For seniors, especially, restraint and precision matter more than broad assumptions. The goal isn't just to supplement. The goal is to support biological function safely and intelligently. And that starts with understanding that even the most well-intentioned nutrients can turn into liabilities when we fail to respect their complexity. Iron is an essential mineral that plays a central role in human physiology. It's crucial for the production of hemoglobin, the protein in red blood cells that carries oxygen throughout the body. It also supports cellular energy metabolism, immune function, and even neurotransmitter synthesis. But as we age, our nutritional needs shift, and iron is one of the most misunderstood nutrients in this process. For adults over 50, especially postmenopausal women and older men, continuing to supplement with iron can often be unnecessary and in some cases even harmful. Let's begin with a key fact. Iron requirements drop significantly as we age. In women, iron needs decline sharply after menopause due to the cessation of menstruation, which is one of the primary ways the body loses iron. Before menopause, women need about 18 mg of iron per day. After menopause, that requirement drops to 8 mg per day, the same as for adult men. However, many people continue taking multivitamins or iron supplements with premenopausal dosing well into their 50s, 60s, and 70s, often without checking whether their body actually needs that extra iron. Unlike water, soluble vitamins, which are excreted when taken in excess, iron is not easily eliminated from the body. The body has no natural mechanism for excreting large amounts of iron except through blood loss. As a result, excess iron is stored in organs such as the liver, heart, and pancreas. Over time, this can lead to iron overload, a condition known as hemochromatosis, which is both underdiagnosed and potentially very dangerous. It's more common in older adults due to the cumulative effect of years of supplementation, dietary intake, and, in some cases, genetic predisposition. Iron overload can damage internal organs, increase inflammation, and elevate oxidative stress. The liver is particularly vulnerable, and long-term iron accumulation can lead to fibrosis, cirrhosis, or even liver cancer. The pancreas may also be affected, contributing to insulin resistance or diabetes. In the heart, excess iron can contribute to cardiomyopathy, a condition in which the heart muscle becomes weakened and enlarged, reducing its ability to pump blood effectively. Beyond the physical organ damage, emerging research also links iron accumulation with cognitive decline. High levels of iron in the brain have been associated with neurodegenerative diseases like Alzheimer's and Parkinson's. This connection is likely due to the fact that excess iron contributes to oxidative damage in neural tissue, which is particularly sensitive to inflammation and free radicals. In short, too much iron may accelerate aging in both the body and the brain. One reason this issue often goes unnoticed is that the early signs of iron overload are vague fatigue, joint pain, abdominal discomfort, and mood changes. These symptoms are easy to misattribute to aging itself, medications, or other chronic conditions. It's only when serious damage occurs that iron overload is recognized, and by then, it can be difficult to reverse. It's also important to consider the bioavailability of iron. There are two forms, heme iron, found in animal products like red meat and liver, and non-heme iron, found in plant foods like legumes, spinach, and fortified cereals. Heme iron is absorbed more efficiently, which means that a diet rich in red meat can lead to higher iron stores, especially in those not losing iron through bleeding. Many seniors maintain their dietary habits from earlier decades, including high red meat consumption, while layering supplements on top, compounding their total iron exposure without realizing it. The good news is that identifying and managing iron status is relatively straightforward. A simple ferritin blood test, along with serum iron and total iron binding capacity (TIB), can give a clear picture of whether your body has adequate, deficient, or excessive iron levels. If levels are high, the solution is often just to stop supplementation and adjust the diet. In more severe cases, medical interventions such as therapeutic phlebotomy, regular blood removal, may be recommended to reduce iron stores. For the majority of seniors, however, the solution is much simpler. Avoid iron supplements unless a diagnosed deficiency is present. If you're still taking a multivitamin and that contains iron, it's worth switching to a formulation designed specifically for people over 50, which typically omits iron for this very reason. And if you're concerned about energy levels or symptoms of anemia, consult your healthcare provider and get your iron levels tested before treating with iron pills. Anemia in older adults can have many causes, some of them unrelated to iron, such as B12 deficiency or chronic inflammation, and blindly supplementing can do more harm than good. In conclusion, while iron remains a vital mineral at all ages, the risk-benefit balance shifts significantly after 50. The aging body stores iron more efficiently and eliminates it more slowly. Supplementation without clear need can tip the scales from benefit to harm. In the context of healthy aging, the focus should shift from general supplementation to targeted, personalized nutrition strategies that are based on actual biological data, not outdated habits or one-size-fits-all recommendations. And when it comes to iron, less is often more.